Hi, can you guys hear me? You can just type in the chat if you can. Okay. Um, like it's completely audible. There's no echo or anything, right? Okay. Cool. So hi guys, welcome to the first session of the ICO Learning Program. So over this program, the structure will be such that in each week we'll pick up a new topic related to the ICO or programming in general. And each topic will give you tests like you had today, and we'll have many sessions like this where we go over both problem solving and theory. So the topic for this session is introduction to algorithms. Okay. Um, Topics in the future will be more specific and like they'll be more theory based. This one in particular was to give you guys a good idea of the learning series and ZIO in general. So before I move forward, are all of you guys familiar with the structure of the Indian Computing Olympiad? Do you want me to go over that? You guys can just write in the chat if you want me to discuss it. Okay, cool. So the Indian Computing Olympiad consists of three different stages. Okay, so the first stage is zonal, in which there exist two Olympiads. There is the zonal informatics Olympiad and the zonal computing Olympiad. Okay, the next stage is the INOI, and the stage after that is the IOI training camp. Okay, so out of the ZCO and the ZIO, you can choose to take either one of the two exams, or you can even take both if you want. Okay, from this exam, around 200 people each qualify for the next stage, which is the INOI. From the INOI, around 30 people qualify for the IOI training camp, and from the training camp, 4 people qualify for the actual international level, which is the IOI. Okay. Now ZIO is very unique to the ICO, which is why we wanted to focus on it in depth. ZIO is unique because it's the only part of the ICO which doesn't require you to know any programming. Okay, the ZIO in particular focuses only on your problem solving skills. So it's a great tool for people who are just starting, and once you find interest in the ZIO, then after exam you have more than enough time before INOI to actually learn how to implement your solutions using code. Okay, so that's the idea for the ZIO. The ZIO in particular has 4 questions, okay, and each question has 3 subparts. Now, all of the subparts require the same logic, but they're just different test cases, okay? So they're the same problem with a different input, okay? And the marking scheme for each problem is as such, okay? If you solve only one subpart, you get 5. If you solve two subparts, you get 10. And if you solve all 3 subparts, then you get 20 points for that particular problem. And so the total number of points per problem is 20, and the total number of points per paper is 80. Aditya Gupta. Yeah, exactly. It's the so like all of the sub problems have the same problem, but just with different input values. That's exactly right. Priyanshu Agarwal, how to watch this class from a laptop? Um, I don't know. You can ask an academy support or something if you're having trouble with that. Okay. I hope the ICO and stuff is clear to you guys. If you want me to discuss further, if you have any questions, you can ask. Otherwise, I'll move on. Okay, cool. So, introduction to algorithms. So, the first thing that we're going to discuss is, okay, before I move on, note guys that we're not actually going to discuss too much theory about what algorithms are and things like that. I'm just going to give you a broad overview, and then we'll jump right into problem solving, because at the end of the day, competitive programming is purely practical. Um, you can ask your question in the chat. I'm actively monitoring it, so as soon as you ask, I'll answer the question. All right. This session in particular is going to be very basic, but the coming sessions will get more and more advanced. Okay. Okay. Now, what is an algorithm? An algorithm is a finite set of well-defined instructions that fulfill some purpose. Okay. Now, each part of this sentence is important. So it has to be a finite set of instructions, right? It even theoretically can't go into an infinite process that doesn't classify as an algorithm. Okay. Well-defined instructions means that the instructions have to be directly understandable and implementable by a computer. Um, and fulfill some purpose means that um, ideally at least your algorithm shouldn't be a bunch of random instructions. It should take some input, perform a very specific set of instructions, and then produce some output, right? An example of a flawed algorithm would be if you just wrote something like, um, example, if you're writing an algorithm to maybe drive a car, right? And you just wrote a single instruction, which is drive a car. That isn't valid because, uh, like, just hearing like the single instruction itself has to be basic enough that it's directly implementable by any computer person or whatever. Okay. Somebody's asking the time gap between ZIO and INOI. So normally ZIO happens in early November and INOI happens in late January. This time the schedule is a bit skewed. So I believe ZIO is happening in late December this time. And if I'm not wrong, INOI, this said will happen later than February, but I don't know exactly when. Okay. So to help you understand what an algorithm is, we're going to look over some very, very basic algorithms. Okay. So the first algorithm will be to find the maximum integer in a list of integers. Okay. So over here we have our input. It's a list in the containing the numbers 5, 1, 9, 3, 8. All right. And I'm sure you guys can intuitively find the maximum number very quickly. But this is just to help you guys understand what exactly an algorithm is, how it's written, so on and so forth. Okay. So the first instruction is to set a variable k is equal to a1. I'm using one-based indexing for the list, and k is a variable we're creating, which will store the maximum variable in the list. Okay. So k is equal to a1. So the initial value of k in this case will be 5. Okay. Then for each I from 2 to n, for people who aren't programmers, this means that we're going to keep changing the value of I from 2 to n, and for each values, we're going to perform all of the operations in that block. Okay. Now, for each I, if ai is greater than k, okay, so if the value at that index is greater than our variable k, in that case, we'll set k is equal to ai. Okay. So on the right, there's a table which will help you understand what exactly is happening. So can you guys just tell me if you can see my mouse pointer on the screen? Okay, wonderful. So in the initial value of k, as I said, is 5, right? Because we're setting k is equal to a1 and a1 is equal to 5. All right. Now, as we go through I, I'll show you how the values keep on changing. So we're at I is equal to 2 right now. All right. So then we go into our if statement. If ai is greater than k. Now, is this satisfied? Ai is 1, okay, because a of 2 is 1, okay, and k is equal to 5. So is 1 greater than 5 is our if statement, and the answer is obviously no. So therefore, we don't access this block, and the value of k remains unchanged. Okay, the next, I is equal to 3. I'm sorry, yeah, I is equal to 3. Okay, now a of 3 is equal to 9, as you can see here. All right, and k is equal to 5. All right, so now is ai greater than k, which is 9 greater than 5? This is obviously true. Therefore, this statement executes and we set k is equal to ai. So therefore, k after this iteration is now 9. All right. Then we move on to I is equal to 4. Okay. But now at I is equal to 4, ai is equal to 3. And k is 9. Now, is ai 3 greater than k is equal to 9? Of course not. So therefore, the statement doesn't execute and k remains the same. And finally, at the last element, I is equal to 5, ai is equal to 8. we check if AI, which is 8, is greater than K, which is 9. It's obviously not, so no. And K after the statement remains the same, 9. And finally, we output K, which is equal to 9. Okay? So, did everybody understand this algorithm, or does anyone have any doubts? It should be straightforward. Beautiful. Uh, Somebody asked, in 1 month of preparation of trying to solve ZIO problems, is that enough to qualify this year? Um, that depends on what your preparation was before you started ZIO, because there's quite a chunk of theory involved and you can't do that just by solving problems. If you were anyways a competitive programmer before doing ZIO, then that should be fine. Ronak asked WHF2. I don't know what that means. Okay. For syllabus of ZIO and things like that, I'll have a Q&A session at the end of this at the end of the class, so you can ask me all these doubts then. Until then, I'm just gonna stick to things that are related to the topic here. But please ask these questions at the end and I'll clarify all of them. Abhinav Kumar is asking, can we use program in ZIO? We can't use any kind of program in ZIO, but you should have a clear idea of the algorithm we're using for sure. Okay. So let's move on to the next algorithm. Okay. Now our problem is, we're given a list A of n integers. We want to sort this list in non-decreasing order. Now, earlier today, someone had a doubt about what non-decreasing order means, and that should be fairly obvious, right? Like, decreasing would mean that it's in descending order. So non-decreasing means that it's in non-strict ascending order, right? Like each element is greater than equal to the previous element. Okay. So we have sample input here, which is 51938, and we have the sample output here, which is 13589. Okay. Now the algorithm that I have defined here is a variation of selection sort. It's kind of like a much simpler version. Okay. So what we do is we iterate I from 1 to n minus 1. Okay. Which is I goes from the first element to the second last element. Okay. And at the same time, we iterate j from I minus 1 to n. So if I is on the first one, then j goes from 2 to n. If I is like on the third one, then j goes from 4 to 5. Okay, that's how the loops are working. Inside, we have an if statement. If the element at j is less than the element at I, then we just swap aj and ai. This is simply because if the element at j is less than the element at I, while j is greater than I, then that obviously means that the elements are out of order, right? Amaresh, isn't it bubble sort? It's not bubble sort, because bubble sorts swap adjacent elements, and the logic of selection sort is trying to find the minimum element and putting it at the beginning, right? So it's much closer to selection sort. It's just an unstable version of it. Okay. It's not insertion sort. Okay, it's selection sort only. Okay, it's a slightly modified version of selection sort. It's not insertion sort, bubble sort, anything else. Okay. So the logic that's being followed here is I is the variable that we want to fix. Okay. So if I is equal to 1, that means that we want to find the element that should come at I is equal to 1. Okay. So what we're doing with j is we're finding the smallest element in the list. Okay. So at the first time, it'll find 1. Okay. And then once it finds 1, then it swaps aj and ai. So 1 will come to the beginning. Okay. You see what we're doing? We're sorting prefixes of the array. So in the first step, sorts 1. Okay. Is my screen lagging, guys? I think it might be your Wi-Fi, because I think it's fine. Okay, yeah, it's your Wi-Fi only. Just try to reload or something. Okay. So what we're doing in the first pass is that we're finding the first element of the sorted array. Okay. So the first time we'll find 1 and put it in the beginning. Okay. So then the second time we'll find 3 and put that as the second element. Okay. The third time we'll find 5 and put that as the third element, so on and so forth. Okay, that's the logic. Now let's look at the dry run on the right and see how it's actually working. Okay. So when so at the beginning I is equal to 1, okay, and j is equal to 2. AI is obviously 5 and AJ is equal to 1, okay. Now is AJ less than AI? That is, are they out of order? And they obviously are, right? AJ is 1, AI is less, so they're out of order. So we need to do the swap, and once we swap them, you can see 15938 is the resulting list, okay. Now the next step is when I is equal to 1 and j is equal to 3. Okay. So over here, AI is equal to 1, right? Because we swapped 1 and 5, so AI is equal to 1. And j is 3, so AJ is equal to 9, right? And we can see that they're in order, so we don't need to do anything here. Same for 1 and 4, right? AI is equal to 1 and AJ is equal to 3. So they're in order and there's no need to swap them. Okay. And again, same for 1 and 5. AI is equal to 1 and AJ is equal to 8, right? They're in order, so no need to swap them. Okay. Then I is equal to 2. And when I becomes 2, that means that we found the correct element for the first position. And that's completely right. Okay. So now I is equal to 2 and j is equal to 3. So are they, so AI is 5 and AJ is 9. Are they in order? Um, yeah, they're in order. That's why there's no need to swap them here. Sorry. Okay. So the list remains the same. Then I becomes 2 and j becomes 4. Okay. So a of 2 is equal to 5 here and a of 4 is equal to 3 here. Are they in order? They're not, right? Because 5 is greater than 3. Therefore, we do need to make the swap. And after we swap them, it becomes 13958. Okay. Then I remains 2 and j becomes 5. Okay. And so the second element is 5. AI is 5. Sorry, I'm really sorry. The second element is 3 because we made the swap there. And the fourth element is, sorry, the fifth element is 8. Okay. And they're in order, so we don't need to swap anything here. Fine. Then again, we check I becomes 3 and j becomes 4. Okay. So we check 3 and 4. Okay. 9 and 5. They're out of order, so we do need to swap them. So it becomes 13598, right? Then I remains 3 and j becomes 5, okay? And the elements there are 5 and 8, okay? These are in order, so we don't swap them, okay? And finally, I becomes 4 and j becomes 5, and the elements are 9 and 8. These are out of order, so we perform the swap. So 13589, that's the final list we end with. And as you can see, it's sorted. Aditya, is swap a function or something in programming? Aditya, swap is just means that we exchange the values um, between those points. Okay. So, for example, if we swap the first and third element in like the initial array, then it would become 91538. Okay. I just joined. What's going on? The X3 we were discussing a variation of selection sort. Okay. After this class, you can go back and see the recording. But for now, we're done with this, and you probably won't need it later in the session. Okay. Okay. So these are two algorithms that we've looked at. Okay. The next step is how do you estimate the quality of an algorithm? Okay. Obviously, there are many ways we can solve each problem. Okay. Even when I was discussing the sorting thing, you guys were giving 3-4 different um, algorithms as an example. Okay. But obviously, some algorithm must be better than others, right? So how do we gauge the quality of such an algorithm? There are two main parameters that we use. Okay, the first is correctness, which is how close your output is to the optimal solution. Now in ZCO, ZIO, and INOI, this is binary, which means either the algorithm is correct or it's not correct. Okay, so you need to like make sure this is right. Later in IOITC and IOI, sorry, Abhinav, listen guys, just ask these small questions at the end, I'll answer. If you have anything related to to what we're currently doing, then I'll answer that right now. Okay? You can put it in the questions tab, I'll look at that after. Okay. Yeah. So like as I was saying in ZIO, ZC and INOI, the correctness thing is binary. Either your algorithm produces the correct output or it doesn't. Okay. However, in IOITC and IOI, you often get problems where there's no perfect solution, and you need to try to make your solution as good as possible. So, for example, it might ask you, um, sort this list in the minimum number of operations, and you need to print the operations. Okay. So in this, there's no necessary right answer that you might expect. Okay. It might be that even if you don't sort it in exactly n squared iterations, even then it'll give you some points. But the closer your algorithm is to the optimal answers, the more points you get. Abhinav, what's the time complexity for selection sort? The time complexity is order of n squared, but I won't be covering time complexity. Okay, I won't cover time complexity right now, mainly because there are like tons of resources that you can use. I'll attach some resources for sure. And also for ZIO, you really don't even need to learn time complexity. Okay. Now, the second parameter is time and space. And at the basic meaning of that is how fast your algorithm runs. Okay. Now, there is a measure of this called time and space complexity, which is very, very essential for competitive programming. The reason I'm not going into details about this is because there are a lot of resources available for this, but this is a broad explanation. Okay, so the XD, what's today's topic? It's introduction to algorithms. It's literally in the title. Okay, so the way we measure the runtime complexity of an algorithm is according to the input parameters that it's given. Okay, so let's look back to the algorithm we were discussing and try to figure this out. So this algorithm, we were trying to find the max integer in the list. Okay, let's look at how many operations we actually did. Okay, we can see that there were 4 dominant steps, right? And one more for set k is equal to a1. So we can say that according to the size of the list, the number of operations we perform will increase in a linear way with the size of the list, right? So we can say that the time complexity for this, one second, where's the pen? Yeah, we can say that the time complexity for this algorithm is, yeah, we can say that it's order of n. This basically means that there are n iterations we would do in such a problem. Okay. Now keep in mind that if you actually want to measure the exact amount, then it would be something like 2 multiplied by n minus 1. Okay. The reason we don't do this is it's like a norm in time complexity that we don't take constants into consideration. Okay. So 2 is a constant value and 1 is a constant value, right? So we can pretty much remove those right away and we're just left with n. Every term in our time complexity has to be based on the input parameter, which is n here. Okay. Yeah, Aryan Rana is correctly right. Is completely right, sorry. Order of n means that the function is upper bounded by c into n for some c, where c is obviously a constant. Okay. Now let's look at our second algorithm. If anybody has any questions relating to this, please ask. Okay. Let's look at our second algorithm. Okay. Wait. Sorry, Ronak is asking, shouldn't the time complexity be order of 1 since no loop is used? Oh, Ronak, a loop is being used. This is the loop. Okay. Cool. Aditya, how is the C determined? The C is like theoretical. It can be arbitrarily large. Okay. The only thing is the C should not change according to the input n. Ronak says we can do 1 by 1. Ronak, you can do 1 by 1, but then again, you can't define an algorithm that way, right? You can't say try A2, try A3, try A4, try A5, right? Because that doesn't adapt to the size of the list. So you'll have to use a loop no matter what. And even if you do it one by one, that doesn't make the actual thing any faster, right? It just increases your constant. Ronak, do you understand what I'm saying? Okay. Like if you choose to write these lines separately again and again, then what Aryan said was that order of n means you can define it as order of, like it won't exceed n into c operations, right? So now in our case, if we keep it order of n, then the constant will be small. C's will be something like 2. Okay. But if you want to remove n, you want to write all these lines separately, then the algorithm won't suddenly become very fast. Okay. The only thing that will change is n will become like what, 1 maybe. I mean, there won't be any n constant, but let's just say n is 1, and the constant will just increase a lot. So then C will become something like 10. Okay. So the actual algorithm just doesn't get faster, just the coefficients get reversed if anything. Okay. So let's look at this sorting example. Okay. Now this one is a little trickier. Okay, because there are nested loops, right? So what this means is that this loop will run n times, for example, and then this loop will run n times each time this loop runs. So let's analyze how many times this actually happens. Okay. So the first time this inner loop j will run n minus 1 times, right? Because you go from 2 to n, so n minus 1. Okay. Aryan, there aren't any prerequisites. I'm doing pretty much everything from the beginning. Okay. Then the next time it'll go n minus 2, right? Because it'll go from 3 to n. And then this will keep on happening, keep on decreasing by 1 until eventually there's only one iteration. Okay. So for everybody here who knows like a decent amount of math, that will be order of n into n plus 1 divided by 2. Okay. Sorry. But like I said earlier, you can remove all the constant stuff. So you can remove the 1. Yeah, n into n minus 1 by 2 because we start from n minus 1. That's my fault. Okay. Thanks, Arjun. And we'll remove 2 from the denominator because again we remove constants. Okay. And so we just get order of n into n, and that's an obvious order of n squared. Does that make sense to everyone? If there's any doubt, then ask now, otherwise I'll go forward. Fantastic. Aryan, I don't want to repeat too much right now, but at the end of the class, I'll put a Discord link that you guys can join where I'm actively answering doubts and stuff, so you can ask any further doubts you have there. Okay? I don't want to repeat the entire thing again, that's the only reason. Abhinav, can we do it in one loop by using I in place of j and I plus 1 in place of I? I don't completely understand that. Abhinav is asking if you can perform this entire algorithm in one loop by using I in place of j, okay, and I plus 1 in place of I. No, Abhinav, I know what you're saying. We can't do that. Try test on this with this algorithm. You'll find that like okay, 5 and 1 will get swapped, so it'll become 1, 5, 9. Then 3 and 9 will get swapped. So you will get, if we do what you're suggesting, Abhinav, you'll get 1, 5, 5 and 9 don't get swapped, 9 and 3 get swapped, 1, 5, 3, 8, 9. Okay. So what you're suggesting is, it's actually interesting. There's an algorithm called bubble sort. I'm sure most of you guys must know it. But bubble sort works on the basis of this. Okay. And yeah, Ronak, we can use quicksort, but it's like you can't do it by hand, right? Okay, cool. So these are the two parameters to estimate the quality of an algorithm. I hope both you guys understand both of these. So that's all of the theory I wanted to do for today. Now I'm going to discuss some of the problems from the problem set you guys hopefully attempted today. Did all of you guys attempt that? Okay, so one person did attempt it. So at the end of this class, I'll put a Discord link here that you should join. And after the test over there, I'll send it to you, okay? But I'll anyways be going over the problems right now. So I'll go over 3 problems right now today, and we'll do three problems tomorrow, okay? Because there's another problem I also want to share with you guys. Okay, so let's go into the first problem, which is, okay, wait, sorry, before I jump into the problem, I wanted to tell you guys my method for solving any problem. So we can use this in our demonstration right now. Abhinav says there are seven problems. Abhinav, problem 4, 5, 6 were the YouTube stream is frozen. Palvi, I'm not sure what to do. I'm not sure what to do about that because I think the OBC is just way too heavy for my laptop. Like it's just lagging. There's nothing else I can do. I can stop and restart again if you want. Palvi, can you ask whoever's there on YouTube to just join an Academy for now? We can upload the recording or something later. Guys, can you just check is the YouTube link lagging? Is the Unacademy thing also lagging or only YouTube? Okay. Yeah, so Palvi, can you just ask people from YouTube to switch over to Unacademy? Okay, the light, my light just went, sorry. Okay, so I'm just gonna move on right now, Palvi, you can figure this out. So these are like 5 steps I usually follow while solving a problem, and hopefully these 5 steps should also help you approach any competitive programming problem. So the first step is to break down the story into a formal statement. Okay. Now for the problem set I gave you, this won't be an issue. But if any of you guys have seen past ZIO papers, then you'll probably notice that the problem statement contains like a proper story format. So the first thing you should do is get rid of all of that and create a short formal statement. Okay. Then the next part is to identify standard and non-standard parts of the problem. Okay. Again, in the problems I gave you today, most of them like are very standard and contain like a one-line solution. But as you go on later in the series, you guys should probably screenshot this or something. As you'll go on later in the series, you will find problems that get harder and harder, and those problems consist of like many different parts. So this is the like a big part of problem solving. Okay. Then the third is you need to observe and prove properties about the non-standard part. If there's any property you come across which you can't prove, then you should disprove it before moving forward. And this doesn't have to be a formal proof. It can be like a logical intuition thing. Okay? And as you keep on proving these properties, your non-standard parts should become standard. Okay? And finally, at the end, when you have an easily solvable problem, then you should first write the algorithm and then find the solution to the test case. Okay, I'll show you guys how to solve some problems using the system, and you guys can pick it up from there. Okay, so let's look at problem 1. Consider the following list of integers: 5, 2, 8, 3, 9, 7, 4, 1. Okay, in one operation, you can swap any pair of adjacent elements. Somebody on Discord had asked me what adjacent means. Adjacent elements just means that they're side by side, right? Like for example, we can't swap 8 and 9, but we can swap like 8 and 3 or like 7 and 4. Okay. Yeah. Cool. So we need to find the minimum number of operations required to sort this entire list in non-decreasing order. Alright? And non-decreasing again just means ascending order. So this is just an example I've given, which is 1, 2, 3, 4, 5. Like it's this list in sorted version. Okay. Now let's go to the previous slide to see our steps. Okay. The second step was to identify the standard and non-standard parts of the problem. Okay. Now this problem is like really simple. So it doesn't have many different parts. It's just a simple statement that finds the number of operations. So we don't have any standard components and we have one non-standard component. Okay. Now the second part is to observe and prove properties about the non-standard part. Okay. So let me propose a possible solution. Okay. You guys tell me if it's right or wrong. Okay. I propose that let's compare the initial list to the final list. Okay. And for each element, find the distance between them. So for example, the element 1, the distance would be 1, 2, 3, 4, 5, 6, 7. Yeah, the difference would be 8 minus 1. Okay, so it's 7. Okay, now for 2, the difference would be 2 minus 2, so it's 0. Okay, then for 3, the distance would be 4 minus 3, which is 1. Okay, and keep doing this for every element. And I think that the sum of all of these will be equal to the answer, which is the minimum number of operations. Okay. Now, okay. So Aryan here has given a logical reason for why my solution is incorrect. Okay. He said that once you make a swap, the distance of some other elements will change, right? So this solution will probably give the wrong answer, right? So what he means is that if I swap 4 and 7, then the distance of 7 to its ideal location changes, right? So you can't just add these distances. This will give the wrong answer. And now to like just be sure that he's right, we can see a simple test case, right? Let's see a test case with 2 elements, 2 and 1. Okay. Now the distance of 2 with its final location is 1 minus 2, which is 1. And we can check again, the distance of 1 with its final location is 1 again, right? But obviously this is incorrect, right? The actual answer should be 1. So therefore, this is a legitimate disproof of our initial suggestion, okay? So now let me propose something else. What I initially proposed was wrong, okay? Let me propose something else. I propose, so let's look at all of the pairs in our list, okay? Like 5, 2, 5, 8, 2, 3, 2, 9, things like that, okay? Now, let's divide all pairs into 2 parts, okay? There are ordered pairs, which are basically pairs that are in the correct order. So for example, 2 and 8 are in the correct order, 3 and 9 are in the correct order, 2 and 7 are in the correct order, 2 and 4 are in the correct order. Okay, so these are ordered pairs. Now let's look at pairs like 8 and 3, 9 and 4, 8 and 1. Okay, these pairs are in the wrong order, right? So let's call them inverted pairs. Fine. Now I propose that for each pair of elements that are inverted, which is like they're not in the correct order, we will have to swap them at least once. Meaning that we'll have to make the actual swap where these two elements are the endpoints. Okay, and we can kind of prove that. Okay, so for a second, imagine that the problem didn't require you to sort adjacent elements. Okay, you can swap any elements anywhere in the list. You can swap 5 and 7 if you want. Okay, now let's look at this. 8 and 3 and 8 and 4 are both inverted pairs, right? So if you can swap any elements, then you could swap 8 and 4, and suddenly 8 and 3 would also become ordered, right? So if this was the case, we could swap any elements, then this property wouldn't be true. This property would be completely false. Okay. However, you do need to swap only adjacent elements. And we can prove that we will definitely have to swap them because consider all of the pairs in the array. Okay, there are some ordered pairs and there are some inverted pairs. Okay, now for the list to be completely sorted, there should be only ordered pairs, right? So now consider any swap. Okay, 7 and 4 is an inverted pair, so let's swap them. Okay. Now after we perform the swap, consider all of the pairs again. Do you guys think that, okay, you guys tell me how many pairs got reversed? Like how many pairs that were earlier inverted now became ordered, and how many pairs that were earlier ordered now became inverted? And yeah, Abhay, don't watch on YouTube. It's glitching right now. Just stay on Unacademy. But can you guys try to answer this? CodeChef says 1. Do you any of you other guys have any answer? Okay, yeah. So he's right. It is 1. Okay. So both 7 and 4 in relation to all the other elements remain exactly the same. Whatever was ordered remains ordered. Whatever was unordered remains unordered. Okay. Only the pair with both 7 and 4 gets changed, right? So that means that for each unordered pair, there has to be a specific swap done between them. Okay. So this is proved. So we can say that this is correct. Okay. Now to prove that this is sufficient, we will also have to say something about the unordered pairs. Sorry, about the ordered pairs which are already in the correct order. Okay. So we can say that if we swap any pairs that are already in the correct order, then they'll become inverted, right? And we've already proven that we have to swap any inverted pair. So this will create an infinite loop, right? Like this will go to this and this will go to this. And like I said earlier, any algorithm has to be finite. So this is false. Okay. I mean, this is also true. Sorry. The statement itself is true. We just don't have to swap any pair of elements that are already in the correct order. Okay. Priyanshu, this class will go until about 6:15. Okay. Sorry, about 7:15. Sorry. Okay. Now, if you guys want a very formal proof about this, it goes like this. Okay. We'll say that the inversions of a list are equal to the number of inverted pairs that exist in the list. Okay. Now, as we proved earlier, in a single operation, the number of inversions can either increase by 1 or decrease by 1 or remain the same. Okay. Now, we obviously wanted to decrease by 1. Okay. Now, we can also prove that in a single operation, you can always decrease the number of inversions by 1. Okay. And this is because the only case where we can't decrease the inversions by 1 is when all of the elements are in the right order, right? And in that case, the list is already sorted, so you don't need to do anything there. So therefore, we proved that the number of inversions can only decrease by 1, and we can always make it decrease by 1. So therefore, the answer will always be the number of inversions in the list. Okay? So now we've done this. We've identified the non-standard parts. We've observed and proved all the properties we have to. Now we have to write an algorithm. Okay? And this is the algorithm that I had written earlier. Okay? For each I from 1 to n minus 1, okay, and inside that, for each j from I plus 1 to n, okay, we say that if a at j is less than a at I, which so basically it's an out of order, we need to increment the answer once. Okay? And we're running out of time, so I won't dry run this in front of you, but you can feel free to try it at home. Okay? And you see that if you run this, you get 16, which is the correct answer. So if anybody doesn't have any questions, I'll mark this as solved. Does anybody have any doubt? Guys? Okay, no doubts then. So let's go to the next problem, which is problem 456. Okay? And these are all the same problem, just with different test cases. Okay? So we are driving a car on a Cartesian plane. We start from the origin 0, 0. From any cell x, y, we can move to, sorry, Nikhil wants to know what the sorting algorithm is called. It's called selection sort. We can move to any cell x plus 1, y, which means move to the right, x, y plus 1, which means move up, x, y minus 1, which means move to the left, and, x minus 1, y, which means move to the left, and x, y minus 1, which means move down. Okay? Each such operation to move to the right, left, up, down takes 1 unit of fuel. Okay? So, in a single, you are only allowed to travel to points x, y such that both x and y are greater than or equal to minus x and less than or equal to, greater than or equal to minus k and less than or equal to k. Okay? So that basically means that it's bounded by a box of with side equal to 2k. Okay? So like in this, you can, I don't know if you guys can see this properly. In the figure here, you can see that the box is of size 4 into 4. Okay, so k over here would, I mean, it's size 8 into 8, but k over here would be 4. Okay, I can't zoom out. Okay, whatever. Yeah, so k over here would be 4. Okay, this is the box of k is equal to 4. Fine. Now, what's the maximum number of distinct points we can visit in a single trip with? So there are 3 different test cases. The first one was with 240 units of fuel and k is equal to 10. The second was with 25,000, k is equal to 20, and the third was 60,000, k is equal to 100. Okay. Now there are certain upper bounds to the number of cells you can visit. Okay, let's try to prove those first. Okay, actually no, let's go according to this what we are written here. So there's no story here. That's fine. Okay, we want to identify the standard and non-standard parts of the problem. Okay. Now, in this problem, that's actually very important. Okay, you can see that. You can see that in each of the parts, we start from the origin 0, 0. Okay. It's always a square plane that you're on. Okay, and the only thing that changes is the size of the square and the amount of fuel you have. Okay, so with that, this amount of stuff, which is completely standard, the solution itself also will not be very complex. Okay, because there's a very high chance that you can figure out almost the entire thing by yourself before writing any algorithm. All right. So first, let's create some upper bounds. Okay. Obviously, the number of distinct points that you can visit in a single trip cannot exceed the number of points in the entire square, right? So first, let's find the number of points that are in the square. Okay, so we want to find the number of points x, y, which satisfy the condition we wrote above, that minus k is less than equal to both x and y, and both x and y are less than equal to k. Okay, so we can write this as the number of values x can take multiplied by the number of values y can take. Okay, so let's find that. Note that the number of values x and y can take are same for both. So let's just find for one. Okay, less than equal to x, and that's less than equal to k. Now again, this is like quite basic math, but we need to just find the size of the range, which is obviously equal to k minus k, which is basically like the upper side minus the lower side, okay, plus 1. So this gives us 2k plus 1, okay. So that's the number of values either x or y can take. I'm really sorry, I don't know why I did that. That's the number of values either x or y can take, okay. And so we need to multiply this twice, right? So the upper bound on the answer is 2k plus 1 whole squared, okay. Now also note that 0, 0 is already visited, right? So the answer is at least 1, and then we can visit at most one new point with each step, right? Like you can move right, left, up, down, and so in each step you can explore at most one unvisited point. So therefore your answer is also bounded by the amount of fuel you have, right? So 1 plus fuel is also upper bound to the answer. So now we would want to find some pattern in which we can visit points so that in each step we always visit some unvisited point, okay. And you can try a lot of things. This is just about trial and error and some logic. Like some person I saw was trying to do something like this, okay. But then the issue is that at this point or maybe later down the line, he'll have to visit some point he's already visited, right? Like if he wants to go down again, he's already visited this. Like this intersection is something you can't have, okay. So after some trial and error, Keshav, this, yeah, sorry, I know a lot of people had trouble with this. So this means that minus k is less than equal to both x and y. Okay, it's like both x and y. It's not a single one of them. Whatever, I'm not writing it, but you get what I mean, right? It's the condition is not for one of them; it's for both of them. Okay, I'm sorry for any confusion this caused. This is completely my fault. Okay, so let's try to find a pattern which will always allow you to visit something unvisited. And the pattern, of course, looks like this. Okay, you start at the origin and you can keep on building a spiral around. Okay, now it should be quite intuitive just from looking at the figure of how we always visit something unvisited with this, right? You can see that there are no overlaps and we're always reaching the end of the square. Okay, if you guys want an informal proof when it's over here, you can screenshot this and review this later. Okay, basically like assume that the car is positioned at the bottom right corner of the previous square. Okay, so let's say we start with k is equal to 0 and the car is at the bottom right corner. Okay, then you can prove that it's always possible to visit this square, reach the bottom right corner, and then leave it. Okay, and so therefore you can look at all this properly later, and by induction this is proven. Okay, but you really don't need to do like write such a formal proof for this, because once you have this intuition of the spiral, It's enough to find the answer. Uh, Vishnu, I know what you mean by 0, 0. Um, Sorry, Abhinav, is it Abhinav? Can you hear me? He's saying I'm coming. Can all of you guys hear me or not? Yeah, so I mean it's fine. Okay. Yeah, Vishnu was saying that 0, 0 shouldn't be included, and yeah, this was also my fault, which is a miscommunication. But don't worry about getting the right answer, the wrong answer. It's just for practice, okay? Like, if you got the logic, that's good enough. I'm sorry about the confusion that the origin caused. Okay. Next time I'll try to make sure that the problems are more clear. So now, once we have this, our algorithm is very direct, right? All we have to do is output the minimum of the total number of points you can visit, which is 2k plus 1 squared. I mean, the total number of points versus the number of points you can visit, which is fuel plus 1. Okay? So did everyone understand how we solve this problem? If there are any doubts, you can feel free to ask. Yeah. Okay. Guys, like Vishnu also asked us right now. It's fuel plus 1 because the origin is already visited, right? So we have to add that. Like, we don't take any fuel to visit 0, 0. So 0, 0 plus fuel. But even if you guys just found fuel, that's good enough. Like, this would have been clarified in an example normally, but my mistake, I didn't give an example. That was my fault. Okay. So we did have another problem planned, but we're running out of time. So I'll cover this problem in the next session. Make sure to come for that for sure. Okay. Uh, for now, look at this information. Okay. So whoever isn't on the Discord live chat, I'd really encourage you guys to join. Like, we're having a ton of fun discussing problems and things like that, and it's a great place to get your doubts cleared. So I know this is not something you can copy, so I'm just putting the link down below. Okay, yeah. I've put the link for the Discord in the chat. Okay, and I've pinned it. So you can fill in the form. We'll send you a Discord invite. Okay. Then furthermore, also please fill in this feedback form. I know the session wasn't perfect, but it was the first one we're doing. So any feedback you can give will help us improve the session in the future. Okay. Use WQZR5GHUOP6W7. Okay. The first form is for the Discord. The second one is the feedback form. Okay. And also, guys, in the next session, I'll be discussing another problem as well. So I want you guys to read about it before you come. Okay. The problem is, yeah, the XTA. I know you can't open the lecture. I'll look into that. A lot of people have reported this problem. So I'll make sure to get it sorted before the next session. Okay. The problem I want you guys to look up is from IOI 2016 called molecules. Okay. I'll just put a link in the description. Give me 1 second. And I'll just put a link there. Give me 1 second. Yeah. You can find this problem here. There are no test cases or anything. Okay. Just read the problem statement and understand. You don't have to try to write code for this. And this is it's like a pretty hard problem. So, like, don't get discouraged if you can't solve it. We'll go through the entire thing tomorrow. Okay. Does anybody have any doubts that are not related to what we particularly covered, or I mean, any doubts in general? Okay, Ronak asked, what resource can we use for practicing ZIO? So, Ronak, I'd recommend you look over previous papers only because there are some 10 years paper available, not 10, even more, like 12 years, and each has 4, so that's a lot of problems. Otherwise, I recommend you solve like Codeforce's A and B problems. I'll put the link in the description. XP, just look at the IO problem. It's not that hard, don't worry. Yeah. Go to codeforces.com. over there, a lot of the Div 2A problems are very basic and they're great for developing problem solving skills. Okay. You don't have to write code, just try to get the logic. Um, okay, there's nothing very specific on this. I know I prediction. Okay, I'm not involved in the decision making regarding the INOI date, so I can't help you with that. Sorry. Okay. If you guys don't have any doubts, then if you have any doubts later, you can email me at my email address. Yeah, no problem, Abhinav. I'm putting my email address in the chat. Okay. You can email me at either of these email addresses. I'll make sure to get back to you. Uh, I'd prefer you I prefer you join the Discord group instead of emailing me because everybody's active on there and it's just easier for me to coordinate. But if you want to email, then that's fine by me. Okay. Thank you guys for joining. I'm gonna end the class. Abhinav, I'll discuss the rest of the problems tomorrow. Okay. Thanks. Yeah, XT, I'm a go. I'm ending the class. Okay. See you guys.